To make an apple pie from scratch, you must first invent the universe. In this lesson, we'll take a look at the scientific worldview. The scientific worldview is captured in the metaphor, the world is an automatic machine. We will tell a 14 billion year story, originating with the Big Bang and the formation of galaxies and stars and planets and the evolution of life on Earth. And what we'll see is the creation of new and more complex things happens automatically, born from the energy of the universe and governed by the impersonal laws of nature. And we will begin our story at the beginning, in what scientists call the Big Bang, the origin of our universe. Someone once said, in the beginning, there was nothing, which exploded. The concept of the Big Bang is difficult to really grasp because, in a sense, nothing turned into something. It's one of the deepest mysteries about the universe. But we're here, and our universe is expanding, and scientists argue that the expansion of the universe today is because at some point in the past, approximately 14 billion years ago, the universe exploded into existence. And ever since its origin, the universe has been expanding. Now, it's not that the universe is expanding into space. Space itself was created in the Big Bang. At first, there was just energy, huge quantities of energy in small space that was expanding. And we can define energy as the potential for something to happen. Now, Einstein's famous E=mc² equation helped us understand that energy and matter are two sides of the same coin. And so in time, as the universe cooled, energy transforms into particles of matter. And matter is the stuff energy pushes around. Some of the laws of nature, the nuclear forces and the electromagnetic force, start to assemble simple atoms from these simple subatomic particles that emerged out of the energy of the universe. And giant clouds of simple atoms like hydrogen and helium would be future galaxies. Another law of nature, gravity, the gravitational force, will condense these giant clouds. And local pockets of hydrogen and helium condense so much that the temperature and pressure gets so high that the hydrogen nuclei fuse to form helium nuclei. And this is called nuclear fusion. And this is what makes stars shine. So the fusion reaction is a process whereby a simple element, hydrogen, is being smashed together to form a heavier element, helium. Now, atoms are the simplest units of elements that have the characteristics of elements. So what stars are doing is they're forging new elements. In fact, after helium is produced, helium can be smashed together to form even heavier elements. So nuclear fusion makes heavier elements, like oxygen and carbon and iron. Now, really massive stars, when they exhaust their fuel, can sometimes explode in what scientists call a supernova. And in the explosion itself, even heavier elements can be produced. Now, the effect of supernovas is important because when a star goes supernova, the shock wave can compress nearby clouds of hydrogen and helium, helping to forge new stars. In addition, the heavy elements that were produced in the original star and in the explosion get mixed with neighboring clouds of hydrogen and helium. So the heavy elements mix. And so when we think about the next generation of stars, it's not just going to be hydrogen and helium. There will be some heavier elements in the mix. And these heavy elements existed as tiny little particles, but they had electrostatic charges, and so they could attract to each other and form slightly larger particles. And pretty soon you have dust orbiting the a new star, and those dust particles that accumulate into rocks, and now the force of gravity can start to help the process, and the rocks will aggregate into asteroids, and asteroids into planets. So initially it might have been a fairly chaotic system of planetoids and asteroids and all kinds of things orbiting in irregular orbits, but in time gravity will stabilize the orbits of these early planets. And so we have the origin of the first solar systems. Now, as it happens, 4.5 billion years ago, in the formation of our solar system, so this being our sun, one of these rocky planets that we call Earth happens to be in the, what scientists call, zone of habitability. That is, it's just at the right distance from the sun so that water can exist as a liquid. And this is important for our understanding of life. Living cells require chemistry, and the chemistry occurs in water. And so, 4.5 billion years ago, the Earth formed, but there was no life. Just a few 100 million years of chemistry happening on the Earth seems to have produced the molecules that self-assembled into the first living thing, a cell. So we get the emergence of life on Earth. So what we have then is that the laws of nature produced new and more complex things in the universe. No intelligence was required for this scientific story. From the Big Bang to early hydrogen and helium atoms, from clouds of hydrogen gas to galaxies and stars, from stellar fusion and supernova to heavy elements, from heavy elements to rocky planets, from rocky planets to life, all emerged over time from simpler things that existed before. There has been a cosmic evolution that preceded the evolution of life on Earth. And we'll pick up the story of life on Earth in the next lesson.